Hi class, it's Mrs. Schnee with Lesson 7, using histograms to answer statistical questions. So at the beginning of the video, we'll go through the lesson, and at the end, I'll remind you that there is a cool down, which is kind of just your way of practicing the lesson on your own, and I will give you the answers that I came up with. I did put a note on the cool down that answers are going to vary on that, so it's more important for you to be able to explain your answer than to have the exact same answer as I do. So today that kind of gives you a hint as to what we're doing in our lesson, where it will be talking about some things that we will be answering statistical questions. Okay? All right, so let's start. Today I have a flag, and it is the Alaska flag in honor of the first question on our lesson. Along with that, I also have a ruler. If you're working through the lesson with me, you might want a ruler that has a metric side to it for question number 1 and 7.2. So if you don't have a ruler yet, go ahead and pause the video, go get one so that you can work through it with me. Okay. All right, so for the first part, it says which one doesn't belong, and there's some questions here. 4 questions. We would definitely spend a little bit more time on this in class, but reading through, it says number 1, in general, at what age do Alaska residents retire? Number 2, at what age can Alaskans vote? Number 3, what is the age difference between the youngest and oldest Alaska residents with a full-time job? And number 4, which age group is the largest part of the population? 18 years or younger, 19 to 25 years, 25 to 34 years, 35 to 44 years, 45 to 54 years, 55 to 64 years, or 65 years or older. Okay, so we're looking for four questions, and we want to know which one doesn't belong. As you know, in our classroom, we've done this before. There's always an answer for everything. So I'll give you a second to think through what your answer would be. Okay, well, when I first read this, the one that stood out to me was this one, number 2. It says, at what age can Alaskans vote? The reason why I thought that one stood out is it's not a statistical question. Not statistical. The reason for that is, once you know the age, it doesn't change. There's no variability. So let's say if it's 18, I'm not sure, but I'm guessing that would be it. If it's 18 and you can vote, then there's no change to it. Every single person's going to answer the same question. Some other reasons. Number 1, it says, in general, at what age do Alaska residents retire? I said that one actually asks more about like the center of the data. It's asking what would be in general or like the typical result. So that could be something that's different about that question. Number 3, what's the age difference? That one, I would say, because it's asking for the spread, like from the youngest to the oldest, it's that would make that question different than the others. And that last one, when it's talking about age groups, that instead of having numerical data is talking about categorical. So they have these like buckets of 18 or younger or 19 to 25. So they have these categories that they're using instead of an actual age. So there you go. If you had a different option, you can send me an email and let me know why you chose that. So now I'm going to go ahead and put my flag over to the side, and we're going to talk about earthworms. I did not bring you any earthworms for this video, but I do have a ruler. It says that for measuring earthworms, we have an earthworm farmer, and he set up several containers of certain species of earthworms so that he could learn about their lengths. The lengths of the earthworms provide information about their ages. The farmer measured the lengths of the 25 earthworms in one of the containers. Each length was measured in millimeters. So it says to use a ruler and draw a line segment. So when you're looking at your ruler, hopefully you have a metric side to it. And each one of these is centimeters, and the millimeters are even smaller than the centimeters. So it takes 10 millimeters to equal 1 centimeter. Okay, so what I did, I already measured these 3. Let's go ahead and do 80 millimeters. I'm going to start right here on my ruler, and I'm going to go over 8 centimeters or 80 millimeters. And that last one, I'm going to go ahead and do 10 centimeters, and that is how long my inchworm would be. Okay, so I remember being a kid and looking for inchworms. They're kind of fun to play with if you can find them. All right, so now we're going to go on to this part. This is the chart that we're looking at that measures the 25 earthworms. I think this was just kind of giving you an idea of how long the earthworm would be, and that's a pretty long earthworm right there. All right, so for this, I want to mention there is data here, and they put it in order from the least to the greatest, which is a really helpful way of displaying that data, especially when we're going to try and put it into a frequency table. So looking at 6, 11, 18, they went through and they put it in order, okay? Also, I mentioned that when we're completing the table for the lengths of the earthworms, I sometimes have a trouble like making sure that I got every single value going from one to the other. So just a helpful hint, like I've shown you in other videos, is to make a tally mark on the side. So each of these should correspond with one of these tallies. So after I went through and tallied, I had 4 in that bucket, and then I have 12 in this category. I have 6 in this category, 2 and 1. So only 1 inchworm was in this range. Also, I put a little note, always make sure that your total matches the frequency. So meaning all of these tally marks should total up to 25 because that's how many earthworms we did. So if we missed one or if we went over, it could really throw off our results for our data and our statistics. Okay, so I counted them up and they did add up to 25. Now down below, we're going to use the grid and the information in the table to draw a histogram for the worm length data. And we're going to label that. So for this one, it says from 0 to 20, there were 4. So what I'm going to do is I'm going to go from 0 to 20, and I'm going to come up and I'm going to make that heavy line right here. Okay, I'll double that over so you can see it. And then that's going to be my first bar. Okay. Now from 20 to 40, there were 12. So I'm going to go all the way up to 12. 20 to 40 will be there. Okay, and then I'm going to bring that down, and that's my second bar in the histogram. You're going to notice there is no space in between these 2 bars, and that's really important with a histogram. It's not a bar graph. All right, so 40 to 60, we're here, and that was 6. So we'll come down and make that bar here. From 60 to 80, there were 2, so I'm going to bring that up just to here. And that last one says 80 to 100, so in between 0 and 2 is 1, so I'm only going to go up a little bit. Okay, there you go. So your bar graph, or sorry, I called it a bar graph. Your histogram should look like mine. Now it says for number 4, based on the histogram, what is the typical length for these 25 earthworms? Explain how you know. So I'm going to give you a little second to think about what would be typical. And remember, when we talk about typical, there's not an exact answer here. And that's sometimes what people get really stuck on or confused about. They always want to know if their answer is right. And in this situation, again, I'll remind you that this could be something that could vary. Your answer could be different than mine, as long as you can back it up. All right, so based on this histogram, what I am thinking is I'm looking at a typical length of being somewhere between 20 to 40 millimeters. And the reason why I say that is it's that highest, so most frequent, and that middle range, if you're thinking about how many, if 25 is our total, just about half of 25 is like 13, 12 and a half. And so that middle score would be in this range, since this was only 4 and this is 12. So somewhere in here in this bucket would be the middle score, also the most frequent score. So that's how I would explain that. Some people might say between 30 and 35. Some people might say in this range, being a little bit more particular here. Okay, but right now our bucket is from 20 to 30, all the way up to 40. So somewhere in that chart, whether you think 20 to 40, or if you want to get it 30 to 35, that would be a little bit more precise. It's up to you. You just have to be able to explain it. All right. Now it says for number 5, write 1 to 2 sentences to describe the spread of the data. Do most of the worms have a length that is close to your estimate of a typical length, or are they very different in length? So when I'm looking back at the spread, remember the spread is, let me see if I can pull it back over. The spread is like from the lowest number all the way up to the highest number, okay, that measurement there. And what I said was most of the worms are shorter than my estimate of 30 millimeters. So some of them are shorter, and most of them are shorter, but they are pretty close to that amount. There are longer worms than 30 millimeters, but not as many that are longer than right in that range. So again, this always trips people up if they have a different answer than me. I'm just saying what I see on the spread, and the way I back it up is just what I said with that middle data, that center part of the 25 values in the chart. Okay. All right, so let's try another one. It says, are you ready for more? I'm not going to spend a whole lot of time on this part with the inchworms, but what I want to make sure you see is that this is the same information of those 25 inchworms. But what we're finding is they have put these in buckets of from 0 to 10, 10 to 20, 20 to 30. So their categories don't match the categories that we had in the first histogram. They had wider, broader ranges here. So because of that, you're going to find that the typical value is not as precise because it's a little bit further away here. It's going to be a little bit more like you can kind of see the spread changed the shape a little bit, whereas this one, the shape kind of, it doesn't have as big of a drop on this one. This one's way up here and then drops down pretty low. And really, that's another factor on when we're talking about looking at statistics, depending on the way it looks and the way that you are interpreting it, the information that you're seeing. People can disagree. As long as you have information that backs it up and can explain exactly why you think that, you'll be fine. Okay, you have that. And we are going to learn more ways in the future and have more of a system to talk about the typical earthworm or the typical basketball player. We'll have a better system as we learn through. I just want you to see the spread, and usually typical is about the center of the data. Okay? All right. So let's talk about basketball players. I know some of you guys like to play basketball, and statistics and sports go hand in hand. And this is talking about professional basketball players and that they tend to be taller than professional baseball players. And here are 2 histograms that show the height distributions of 50 male professional baseball players and 50 male professional basketball players. Now our first job is to look at both of the histograms and make an educated guess as to which one you think is about basketball players as opposed to baseball players. So go ahead and look at those 2 and see what you think. All right, so when you're looking at them, are you noticing that there's a difference in the way that the data is spread? So for instance, this one, the lowest data is 70, and the highest looks like close to 90, okay? And then down here, we have a spread between 66 and 80. So this one would be a longer or taller because we're talking about the height distributions. So if you think that A would be basketball, I would agree with that. These would be the basketball players because we talk about them typically being taller than the baseball players. Okay, so just seeing that highest and even the middle point of the spread, like even the middle would be higher, where the middle here is around 72. Over here it's between like 79 and 80. Okay, So down below it says write 2 to 3 sentences. I didn't really do sentences. Don't tell Mr. McGee or Miss Brown. I just put some little bullet points here. So we're trying to describe the distribution of the heights of the basketball players. So again, that's looking at that top or A histogram. I said that the cluster for A is located higher on the number line. So looking at this number line across this x-axis, it seems a little bit higher in numbers for where it's grouped together. And then also the center is about 80 to 81 inches, so right in that zone I was talking about before. And most players are within 6 to 7 inches of the center. So thinking about, you know, having most of the chunk of players being in that range, it's pretty close together. There, of course, are some people that are shorter and taller than that middle range, but for the most part, most of the basketball players are in there. Okay, now down below that, we're talking about the baseball players. So I noticed with that, it's centered closer to 72 inches. So that center part is lower than the basketball players. And all players are within that 6 to 7 inch range. So they're not as spread out. There's not so many like really tall or really, lot shorter of the baseball players. They all seem to be closer in height than the basketball players. Okay. So hopefully you saw that and that didn't make too much of a concern there. And that's really the main thing that you're going to see with histograms, is being able to kind of understand from the visuals what's happening in the histogram. Okay. All right, so we're down to the lesson summary. Here are the weights. So they gave us weights of 30 dogs. And if we were to make our own histogram, the best thing that we could do is consider some of these questions. We would look for the smallest and the largest values in the set of data. And they did something for us here where they put it in order with the lowest here and the highest here. Now, if you were taking your own measurements of 30 dogs, you might have your numbers all jumbled up, and then it might take some time to put them in order from least to greatest, but I think it would help you very much in the future to put those sets of data into an order of least to greatest, and you'll see in the future when we're talking about median and mean and all of those concepts that we haven't quite gotten to yet, why it would be important to do that. I also highlighted down here just that understanding of the smaller the bins, or the smaller the little categories that we're setting up, the more bars we're going to have. And an example of that is back to our inchworms. This is when we had some wider ranges from like 0 to 20, 20 to 40. But then when they changed it and they did from 0 to 10, 10 to 20, they made more groups. So then each one of those groups was more specific. So that shows you that we had more bars there in that histogram. Okay, so just a quick reminder of that. Now they took all this information and put it into a frequency table, and then next they put it into a histogram. So just one more example of how that would look with the dogs, and we're seeing that there's a gap here from 0 to 10 because there weren't any dogs in that range, so we can leave that there. But there were dogs all the way from 10 to 34. And what they did was they put them in ranges of 5 kilograms each time. So 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. They could have done it differently. They could have gone in groups of 2, like 10 to 12, 12 to 14, 14 to 16. But maybe they had, they wanted to break it down where there wouldn't be so many bars. So it really just depends on the question and what you're getting the information from. Okay, so they took that minimum and that was their lower end. And then since the minimum was 34, they didn't stop at 34, they went all the way up to 35 to make it consistently 5 kilograms in each bin. Okay. All right, so today's lesson, really the main idea is to see that not only can you get information and answer questions from the other types of graphs, like we did a line plot and we've done a bar graph. We've done those too, but now we're working with histograms, and we can also answer statistical questions when we're using histograms. Okay, Now it's time for you to look at your Using Histograms cool down, lesson 7 cool down, A Tale of Two Seasons. I think it has to do with basketball again, does it? Yeah, basketball again. Shout out to all our basketball players. And go ahead and answer those, and then pause the video while you're doing that, and then unpause it so you can check your answers. Remember, your answers might vary. It may not be exactly the same as what I would do. Okay? All right, so now I'm going to go over the answers that I have as far as the cool down. And we have 2 different histograms, and they're showing that they're points scored per game by a college basketball player. And this college basketball player played in 2008, and they played in 2016. Huh. Is it the same player? They were in college for a very long time. Pretty funny. Okay, well anyway, we'll go with that. Now we see what is a typical number of points per game scored by this player in 2008. So what about in 2016? So what I said was in both seasons, the player typically scored around 15 to 20 points in a game. In each histogram, the typical score should be around the center of the spread. So when you're thinking about the center, we're looking at this kind of distribution, and that middle point was around there. Okay, and then if you look here, it's kind of spread a little bit more evenly, but again, the spread is right in that same range. Okay, now it says write 2 to 3 sentences that describe the spreads of the 2 distributions, including what spreads might tell us in the context. So the spread was more narrow in 2016. So here's from 0 to 35, those are his point spreads, or hers. Now, in 2008, there was more of a range. And it says that that player was more consistent in 2016, but had a good game in 2008 where they scored quite a bit of points. And so that changed the spread, where they just had a really good game that game. So it didn't trail off. It went a little bit further over. Okay? So that's what I have for you on this Tale of Two Seasons. We will definitely have to wonder about why this person was in college in 2008 and then playing still college basketball in 2016. That's a mystery that this video will not be solving. Okay? Well, hopefully you guys had some fun learning about histograms. I know it's probably not that much fun, but I do appreciate you guys watching the video. Okay? And let's fly our Alaska flag. Yay! Bye-bye, guys.